Hey y'all, welcome back to Alakazam Math Made Easy. In the last video, we went over some of the more central rules for how to pretty much quickly go through derivatives one term at a time, right? So in video 10, we talked about how you can take the limit as h approaches 0 of f of x plus h. Is this whole process that involved expanding it and then canceling stuff back down. It's really tedious, right? So we came up with these four essentially tricks, right? To make that process faster, right? And as you remember, this you should this first one you should almost find intuitive, right? But these three down here, you really need to memorize, right? And my recommendation is to start making flashcards of these things. I'll put a link to a Quizlet that has these already. But my recommendation would be to really start memorizing them now, because in 3 more videos, we're going to introduce 6 more rules. So you might as well start memorizing them as we go, right? So here are those rules. The issue that we have with these rules is that they're great for super simple cases, right? Like 40e to the x, it's a simple case. But what happens if, say, these two functions are multiplied together? We don't know how to do that yet. So that's what we're going to go over in this video. That and what happens if they're like divided, right? So that's the product and quotient rule. So, like I said, we don't know what to do yet if these two functions are multiplied together or divided, right? Any two combination of functions, we don't know how to do that yet. So let's start with the first one, right? Product rule. This is the situation that you have two functions, two distinctly different functions multiplied together, right? So this is the structure for product rule, right? We have function 1 and function 2. They're not possible to simplify them, combine them, turn them into a polynomial, or turn them into something that will follow one of those 4 rules. We just have to keep them multiplied together, right? So we have function 1 and function 2. The derivative of that is given by this function here that kind of is explained right below it, right? So basically what this function is saying, that if I'm given u of x times v of x, right? I take the derivative of the first one, the derivative of u of x times v of x left alone. So just as it's written here, it stays right here. And then I add it to the first function just as it's written, right? Just as it's written here, it'll be written over here, times the derivative of the second function. So we have the first function times the derivative of the second function. And I'll explain a couple examples, and I believe we'll go through, yeah, I'll explain 2 pretty quickly, and then we'll go over one together pretty intimately. That goes over a bit of a special case, but that's the actual function, the equation, I mean. So this first example, right? We have 4x squared, which is a polynomial, right? And we have e to the x, which is an exponential. So we can't combine those and distribute or do whatever to make them follow one of the rules listed above. So we have to follow product rule. So what I've done is I've written out the definition of product rule here, and we'll basically just plug and chug to fill it out. So, like I said, the first step is take the derivative of the first function, right? And the first function is 4x squared. So y prime, remember this is a polynomial, so what we're going to do is take this, multiply it to the front, and do -1. So the derivative is going to be 2 times 4 is 8x to the 2 minus 1 is 1. So that's where that 8x comes from. Then the next step, we leave v of x, the second function, exactly how it's written. So that's why it's e to the x. It stays exactly the same. And then we add, so that's the first piece. Then we add to that the first function left exactly how it is. So there's the first function. Here's how it is. It's the same. And then what we do next is we take the derivative of the second function, right? And in this case, because the second function y equals e to the x, e to the x has the same derivative as the function. So y equals e to the x, the derivative of that stays e to the x. So there's that. And then technically, this is the correct answer. You can leave it like that for some professors. Others make you simplify it all the way down. So the first thing I did is I pulled out an e to the x and I made it up in the front. And then I'm like, okay, well, now I have to figure out what these all have in common. And I found that it has a 4 and an x. So then I pulled out the 4x as well. So that's that. Some professors don't necessarily make you do that, but others are pretty stickler about that. So keep that in mind. Good practice either way. The second function we'll go through a little bit faster just for the sake of time. Again, first one, 2x cubed. We're finding the derivative. You take the 3, multiply it to the front minus 1. We have 6x squared. That's where the 6x squared comes from. And then again, you multiply that by the second function left exactly how it is. That's why ln of x stays ln of x. The second piece, you leave this function exactly how it is. So that's why it's 2x cubed. And then you multiply it by the derivative of the second function. So for the second function, y equals ln of x. The derivative of ln of x by definition is 1 over x. So that's where that 1 over x comes from. So again, then we simplify. In this case, there's nothing that can come out of all of these, I don't think. Oh, well, I guess there's a 2 that can come out, but we'll do that at the end. So this term you can multiply, and then this x cancels with one of those two. So that's what's happening right here. And that's what we're left with. But again, I forgot a step. You can take a 2 out of here and a 2 out of here. So what we'll do is we'll do 2 times 3x squared ln of x plus x squared. And that'll be our most simplified answer. Awesome. So what I wanted to do for product rule is walk through a complicated case, right? So the first thing that we're going to do, this most complicated case that you could probably have with product rule is the case where there's 3 things being multiplied together. So if you remember, the function for product rule only accounts for 2 things, right? So what's going to end up happening is we're going to have to do a product rule inside of another product rule. So it's going to be a little bit exciting. So what we're going to do is we're going to start by calling this the same function. So this is going to be function 1, and this is going to be function 2. But obviously within function 1, we have 2 functions. So we'll get there when we get there, but we're going to start like that. Okay. So again, y prime, yeah, I'll write it in orange. Y prime is u prime of x times v of x plus u of x times v prime of x. Okay, so let's jump right in. So y prime, we're going to take the derivative of our first function, right? And our first function is another product. So by taking the derivative of that, we're actually going to be taking the derivative of another product rule. So inside of that, we're going to do another y prime is u prime of x. We'll call it different from u. We'll call this a of x and b of x. So what we're going to do is we're going to do a prime x times b of x plus a of x times b prime of x. So let's do that first. So a is 2x squared. So the derivative of 2x squared, 2 times 2 is 4. X times 2, or to the 2 minus 1 is 1. And then times b of x left alone plus a of x left alone, 2x squared times, times 6x to the 1, that's an understood 1 right here. 1 times 6 is 6, x to the x minus 1 is 0, which just means 6, right? So that is the derivative of that first piece, but remember that's only this far. So that's what we're going to call this, but we have to write the rest of the function, right? So it's that times v of x, which remember, if this was u, if this piece here is u, then this piece here is v. So v of x is just e to the x left alone, plus a to the x left alone. So that's 2x squared times 6x times the derivative of v. And v equals e to the x. So v prime equals e to the x still. So it's a super complicated approach, but that's pretty much it. From here, we just simplify. So that still, even though it was a product rule inside a product rule, it was only one line of work. So that's the beauty of product rules. It's pretty approachable. So let's simplify this a little bit. So y prime, I'm going to combine these terms, right? Because those are all polynomials, so they have to be combined in some way. So this first term becomes 24x squared plus 12x squared. And then that whole thing is times e to the x. And then we're doing plus 2 times 6 is 12. X squared times x is x cubed, e to the x. And then simplify one more time. These two can combine to 36x squared, e to the x, plus 12x cubed, e to the x. So what do these have in common? Actually a lot. So they have a 12 in common, so this is going to be 3. They also have an x squared in common, so this will become 2. And they have an e to the x in common. So our final answer is going to be y equals 12x squared e to the x times 3 plus x. And that's our final answer for that. So honestly, from my perspective, once you get comfortable with product rule, even in a case like this, the most annoying part is going to be simplifying. So my recommendation for product rule, practice it over and over and over and over and over again, because the process is exactly the same. So once you get used to doing the process, these problems will be a breeze. So we've gone over the case of how to handle things that are being multiplied, but how do we handle things that are being divided by one another? And this one is a little bit, in terms of formatting, it's a little bit annoying. So I'm going to present the formal language, but I'm going to use the language that my teacher, when I learned this, used, because it's a little bit of like a jingle almost, and it'll help you remember it, I think. So again, we're using u and x, right? U is going to be the numerator, v is going to be the denominator. So the definition is right here. So that's the formula you can use. And I'll go into what it means with this jingle because I think it actually explains it a little bit better. So what we're going to do is we're going to call u high because it's on the numerator, and we're going to call v low because it's on the denominator. And then what we're going to say is y prime, so the derivative, right? That's the goal. We're finding the derivative of this function. Y prime is low d high minus high d low over low low. So what does that mean? It's a jingle. It's kind of catchy. Say it like 10 times in the mirror or whatever, and you'll probably remember that. Low d high minus high d low over low low. So what does that actually mean? Low d high means you're taking the bottom function, the denominator, leaving it as it is, multiplying it by the derivative of the numerator. Minus is pretty self-explanatory, but you're doing minus high d low, which means the numerator is left alone as high, that's high. D low is you're taking the derivative of just the denominator over low low, which just means you're taking the denominator as it is and squaring it. So that's a little bit of a jingle to mean the same thing, and that's what I still use to this day. So I'm going to go over this example a little bit slower, and then the following one a little bit quicker, and then we'll do one together that combines quotient rule and product rule. So this first one, we clearly have two different functions. Here's my low, or I'm sorry, this is my high because it's in the numerator. Here's my low. So we'll jump right in. So low, we leave the denominator exactly the same. D high, we take the derivative of this. So if you're taking the derivative of D high, y is 2x cubed plus 6x. And remember, it's a polynomial, so the rule is multiply this to the front minus 1 and multiply this to the front minus 1. So y prime is going to be 3 times 2 is 6, x to the 3 minus 2 is 2, plus 1 times 6 is 6, x to the 1 minus 1 is 0. So that's where that comes from, 6x plus 6. So that's low D high. Minus, again, pretty self-explanatory, the minus part. High, left alone. So we're just going to rewrite it, 2x cubed plus 6x. D low, and remember, this is low, y equals 5 ln of x. And remember, the rule for natural log of x is 1 over x. The derivative of natural log of x is 1 over x. And if you simplify that, you can just multiply this 5 into the numerator. You get 5 over x, which is where that comes from here. And then again, the denominator, so we have, or for the numerator, we have high d low minus low d high. Oh, what? Sorry. We have low d high minus high d low over low low. So what we have to do then is take this piece here and square it. So 5 squared is 25, and the natural log of x squared, you can just leave like that. So there's that. That's the first example, and then we simplify it. Really, there's not a ton you can do. I believe what I did was I canceled this x here, and then that was pretty much it. So for this next example, we'll fly through it a little bit quicker. Low, we leave it alone. D high, we take the derivative of it. E to the x, the derivative is e to the x, so that's nice. We don't have to do much there. And then high, we leave that the same. And then D low, ignore this blue for a second. D low, we're going to take the derivative of 2 log x. Remember, log, the derivative is natural log of 2 times x, because the base, oh, I'm sorry, I must have erased this. So yes, so 2 ln of 2, because that 2 is here. So working forward, we then have to, oh goodness, we then have to square the denominator. The denominator is 2. So 2 squared is 4 times log base 2 of x. So we're going to do log base 2 squared of x. Boom. And then we simplify. But one of the things that we have to take care of when we simplify is the fact that this piece here has a denominator in the numerator. So if you remember, this piece you move to the bottom. So that's what we did to simplify there. So this next one I wanted to work through together because it's a combination of product rule and quotient rule. How do I know that? It's because, first of all, there's a fraction. Anytime there's a fraction and you're taking the derivative of it, that's a quotient rule. But in the numerator of that fraction, you have 2 things multiplied. So here's my 1 and here's my 2, right? So what we'll do is we'll jump right in. So my recommendation is look at this from you have to look at it from a quotient rule standpoint. So remember, y prime equals low d high minus high d low over low low. So let's jump right in. Low stays the same, so 3 natural log of x. D high, now we have to throw in product rule. And remember, product rule says y prime is u of x prime v of x plus u of x times v prime of x. So looking at this, our u prime of x is going to be the derivative of this 4x squared. So that's going to be 8x to the 1, or 8x. And then v of x is going to be staying the same. and all that has to be in a bracket, plus u of x stays the same, 4x squared, times v prime of x, that stays the same because it's e to the x. So that gets rid of this piece. And then we'll do the rest. So minus high stays the same, 4x squared, e to the x, times d low. So we have, remember, natural log of x is 1 over x, but we have 3 times that. So we have 3 times 1 over x, which is 3 over x, over low. So we have 3 squared is 9, and then natural log of x squared. So we can simplify this probably a little bit. Let me see. First of all, we can pull out an e to the x here. So we have y prime equals 3 natural log of x times, we have an e to the x in common, we have a 4 in common, and we have an x in common. So we'll call it 4x e to the x. And then what we'll do is we'll multiply it by this addition, right? So we canceled this x. This was divided by 4, so there's 2. We got rid of this. This went away. We only divided by 1x, so that leaves an x behind. So what we'll have is times 2 plus x. And then that whole thing is minus, what can we do over here? We have an x in the denominator that can cancel with one of these x's. And then we have a 3 times a 4. So what we'll do is we'll do minus 12x e to the x over, let's see, over 9 ln x squared. Now let's see, we can simplify this one more time actually, which is pretty cool. So if you have this 3 and this 4 multiplied, they become 12. So what we're ending up doing is we're going to say, we'll get rid of this 3 and then make this 4 into 12, which is nice because if you look at this, now we have a 12x e to the x in common in these terms. So what we'll do is we'll pull that out, 12x e to the x. So now we don't have that in this term anymore or this term. And that leaves us with the natural log of x times 2 plus x minus 1 over 9 ln of x squared. And if you wanted to be really enthusiastic, you can cancel this 12 and this 9 because both are divisible by 3. And so your most simplified answer would be 4x e to the x times the natural log of x times 2 plus x minus 1 over 3 natural log of x squared. Awesome. So that's your most simplified answer. So my recommendation for this whole section, right, is to get super familiar with product rule in its simplest cases, right, in the 2 function kind of cases. And same thing, get familiar with quotient rule in its simplest case, like just 2 functions being divided. But know that on an exam, you'll likely have at least one question that takes it a little bit further. So you probably won't have both of these situations, but I would guarantee that you're going to have at least a double product rule or a product quotient rule. So in the immediate, my recommendation is to practice the individual rules themselves. In the long term for exam prep, my recommendation would definitely be to combine these rules a little bit and study them together, right? So if you learned something from this video, please like it. If you have questions, you can leave them in the comments. I'll answer them. If you want to stay up to date on the videos that I keep posting, subscribe to my channel and press the notifications button to toggle them on. And otherwise, best of luck.